All right. So, good evening, everyone. Let's start, Nick. Today, we are talking equations. Equations. We can categorize equations into three according to your syllabus. Correct? So, the first type is simple equations. Simple equations. These are the type of equations you have been talking since grade 8. Since grade 8, you are talking simple equations. And then there are simultaneous equations. Simultaneous. So simultaneous equations are introduced to you in grade 9 and continued till O levels. Simultaneous equations. And then finally, you study quadratic equations in grade 11. Quadratic equations. So this session will mainly focus on simultaneous and quadratic, since simple equations are pretty easy to understand. We'll just look at simple equations first, and then we'll quickly jump off to simultaneous equations. First of all, let me make clear the difference between an expression, and an equation. So simply, an expression is something you write like x plus 5. This is an expression. Correct? A plus b minus c. This is an expression. Right? So an equation is something with the equal sign included. The equal sign included, and on the left and right there's some value. X plus 5 equals 0. X plus 5 equals y. A plus b minus c is equal to 2 plus z. So these are equations and these are expressions. So an equation definitely must have two expressions on both sides. Two expressions, like 5 is equal to 2 plus a. So is the difference understood? The difference between equations and expressions, is it understood? Yes. Simple, ne? The main difference between an equation and an expression is the equal sign. So if there's an equal sign and there's values on both sides, then it is an equation. You can identify with the equal sign. If there's no equal sign, it's just an expression. Right. So let's move on to simple equations. In simple equation, we have only one unknown value. One unknown. That's why it's called a simple equation. For example, all of you guys here might have come across simple equations. Let's see, I'll give you an example. So x plus 4 is equal to 9. This is a simple equation. What's the unknown here? What's the unknown? X is the unknown, right? X is the unknown, and you will have to find the value of x. So in finding the value of x, you can easily subtract 4, like the extra stuff, you have to subject x, that's it. In order to subject x, we are moving the extra stuff to the other side. So x is 9, this positive 4 becomes negative when moving to the other side. So now x is 5. This is clear, I guess. Is it clear? Yeah, simple equation 5. Simple, since grade 8 you have been doing this. Correct. Now I'll give you another simple equation to solve. Find the value of x. X is 5, eh? So, yeah, the same thing is done here. You remove the unwanted stuff to the other side. Like we have to subject x. So there's an addition and a multiplication. We remove additions first. Additions are easier to remove. Like in BODMAS, we do multiplication first. In subjecting, we do the reverse. Additions are removed, subtractions are removed, and then only multiplications are removed. See, the 2 is removed first. So 3x is equal to 17. 17 minus 2. 3x is 15. Now we can divide both sides by 3 and x becomes 5. Is this clear? Yeah, x is 5. That's clear, eh? Hi. So the fundamental rule for a simple equation is there's only one unknown. So if there's one unknown, you can solve it using this method. Using this or your own method, which you find accurate. Correct? Okay. Now let's try the simple equation in the example in the table. It's 3x plus 2 x minus 10. Please change this 9 into 12. This must be 12. That's not 9, this must be 12. Now you can try. Try this out. This is again a simple equation. There are two x's, but the same value, no? Same unknown. So this is a simple equation. There's only one unknown. See, x is the only unknown in this equation. So you can solve it and send your answers. I've been receiving answers, but none of them are correct, I guess. Let's see. Yeah, I have received a correct answer, but let's try this out. This is no big deal. First, there's two ways, like people follow many ways to solve this. Mainly there's two ways. The first way, I'll do the first way here and then we'll go for the second here. The first way is to eliminate the numbers outside, like outside the bracket. If this is divisible by 3, we can remove the 3 by dividing. Is that understood? Like we can write x plus 2x minus 10 is equal to 12 divided by 3. Is this understood? This is one method. We can divide the coefficient, divide the number if this is divisible. Good. So we get x plus, we must distribute the 2 in x plus 2x minus 20 is equal to what is 12 over 3. 12 divided by 3 is 4. So now we can simplify. X plus 2x is 3x. 3x minus 20 is 4. So 3x is 4 plus 20. 20 becomes positive. Now 3x is 24. So x is 8. We divided both sides by 3. Is this clear? Is this clear? Good. Good. Alright. So this is one method. The next method is identical. Just a small difference. We don't divide this by 3. We expand the whole equation. Like we expand the whole left side. See, I'll write this 3x plus 2 into x minus 10 equals 12. We are going to expand this. First, simplify the bracket. X plus 2x minus 20. 3 is in the outside. So equal to 12. So 2x minus 20, 2 gets distributed. Now inside 3x minus 20 equals 12. 3 is still here. Now we are going to multiply this by 3. 9x minus 60 is 12. And you can solve 9x is equals to 12 plus 60. 9x is 72. Again, x is what? X is 8. Are the both methods clear? I prefer this one. This is pretty simple than this. So you can do either. You can either divide the numbers or you can expand them and solve. Both are acceptable. Good. So let me know if simple equations are perfectly all right for you. Like simple equations okay. Like this is the best simple equation someone can give. Like every operation is there. There's division, multiplication, addition, and subtraction. Right? Okay. So we are not gonna stay. Yeah. Another example. Okay. Sure. Okay, I'll give you another question. See. Let's do another question. Give me a minute. Let's solve. Wait. Make this 6. Sorry, yeah? Make this 6. Good. Yes. Yes, I'm receiving answers. Good. Yeah, they're correct. So let's do another one. Like the answer for this is 3. Let's say 6 is equal to 2x plus, we'll have to expand this, 3x minus 9. So 6 is equal to altogether 5x minus 9. We can move this 9 to this side. 6 plus 9 is 5x. So 5x is equal to 15. X is 3. This is clear. So the last example. Yes. The answer is 7. Yes. See, 3x minus 4 gets distributed minus 4x, and here minus 4 into minus 2. Minus into minus is plus, so plus 8 is equal to 1. 3x minus 4x, that's clearly negative x, minus x plus 8 is 1. So we can make the x positive by taking it to this side. 8 equals 1 plus x. So we can take this 1 to the other side. X equals 7. X is equal to 7. So that's enough now for simple equations. That's enough now. I guess that's enough. Yes, good. Because they won't ask a direct simple equation in your exams, but in order to solve simultaneous equations, you will have to know how to solve simple equations. Now let's move on to simultaneous equations. So, in simultaneous equations, how many unknowns are there? There are 2 unknowns. So, in order to find 2 unknowns, one equation is not sufficient. Right? In order to find the value of 2 unknowns, one equation is not sufficient. Therefore, you need 2 equations here. You need 2 equations. Definitely, you need 2 equations in order to solve a simultaneous equation. Before that, let me know if you have an idea of what is meant by this. What is meant by a coefficient? Do you have the idea of a coefficient? No. Okay. Coefficient. So a coefficient is simply exactly the number before an algebraic term. Like, see, I'll write an expression. See, this is a pretty long expression. Well, let me know the coefficient of A. What's the coefficient of A here? The coefficient of A is 7. Yes. The coefficient of A is 7. See, the number associated with A, the number before A, the number which from A is multiplied. Alright. What's the coefficient of X? 3. Good. The coefficient of X is 3. Plus 3. Means positive 3, but positive. Okay. What's the coefficient of Y? There are 2 Y's. Sorry. I'll make this something else. What's the coefficient of Y? It's minus 4. The coefficient of Y is 4 negative. So minus 4. It's minus 4. And what's the coefficient of M? The coefficient of M is not 0. There is a number. M is multiplied by minus 1. So the coefficient of M is minus 1. It's 1 but negative. The coefficient of, like, if I write a letter A, what's the coefficient of A? Here. It's 1. It's clearly 1. Because if you multiply something by 0, it becomes 0. So in order to generate A, I'll have to multiply A by 1. So A's coefficient is 1. Coefficient is 1. Cool. So now you guys got the idea of a coefficient? Of what a coefficient is? Right. Alright. Now let's move into the lesson. So I'll give you an example for simultaneous equation. It's like this. X plus y is 4. X minus y is 2. Like, they definitely give you 2 equations, or else they give you a passage or something, a scenario. You'll have to build up 2 equations. Let's see how to build simultaneous equations, how to construct them. At the basic level, they give you 2 simultaneous equations. and they ask you the values of the unknowns. What are the unknowns here? What are the unknowns? The unknowns are x and y. So you definitely need two equations to find the values of x and y. X y you will definitely need two equations. So when solving simultaneous equations, the first step is we'll have to name these equations. Like this need not to be numbers at all. Like you can name this a and b, but as a norm, as a tradition, we are naming this the first equation and the second. This can be letters, this can be a, this can be b, no matter. We are naming equations for the sake of easiness. And then we follow two methods to solve simultaneous equations. The first one is the method of elimination. The method of elimination. And the second one is the method of substitution. Let's see what elimination and substitution means. Like, do you guys know the meaning of the word elimination? Like in simple English? Do you guys know the meaning of elimination? Eliminating something? Yes. One getting out. Yeah, removing, putting out, exactly. Like killing, yes. So eliminating means we are going to remove that guy out of the equation. Here's two unknowns. We are going to eliminate one unknown out of the equation. If you eliminate one unknown, what kind of equation do you have then? Simple. Yes, like there's two unknowns. If you eliminate one unknown, that's going to be a simple equation. Now you guys know how to solve simple equations. You guys know how to solve simple equations. So the goal is to make this a simple equation and solve one by one. Right? That's the first step, elimination. So let's refer the tute. Steps sticker. So one person is asking, should y be eliminated? That's up to you. Like you can eliminate y or else you can eliminate x. You must decide. Let's see how to decide. So the first step is choose which unknown to eliminate. So somebody can say, I want to eliminate x. Someone can say, I want to eliminate y. No matter. You must choose. In this case, I'll choose y. I'll choose y. I'm going to eliminate y. Eliminate y. I'm going to eliminate y. So let's see what must be done. Make the coefficients equal. They are not talking about the signs. They are talking about the coefficients. No matter whether it's positive or negative, what's the coefficient of y? It's 1. It's positive and 1. So what's the coefficient of y in the second equation? It's also 1. It's negative 1, but it's also 1. The value of the coefficient is 1. So the coefficients are equal. Is it understood? The coefficients are equal. So the second step is also done. Like the first step, we chose who to eliminate. And the second step, we check if the coefficients are equal. They are equal. And then they are talking about the signs. Are those signs equal or different? For both y's, the signs are equal or different? The signs are different. Then what must we do? Refer the tube. Yeah, we must add. If the coefficients are different, we must add. If different, we must add. If equal, we must subtract. So the signs are different. So we gonna add the two equations. Okay, plus. Let's add. We're gonna add the first equation with the second one. So as we did yesterday, by adding two equations, we must add the left side separately and the right side separately. Addition: x plus y plus x minus y is equal to 4 plus 2. So see, y gets eliminated. Y got eliminated. Now there's a simple equation. X plus x is 2x. Here it's 6. Now the value of x is what? 3. Is this understood? Yes. Okay. We are going to do more examples today, but this example, is it understood? Is understood me? Correct. Okay. Now we found the value of one unknown. We have one unknown. So the method of elimination is over. Now I'm going to substitute this value. I'm going to substituting x equals 3. I'm going to substitute this value in either of these two equations. Like I can use the first one or the second one. So I know the value of x. I'm going to substitute it in 1. Like you can choose to, no matter. You will get the same answer. I'm going to substitute x equal 3 in 1. That's the second step. So if I substitute x with 3, 3 plus y is 4. Now what kind of equation is this? Yeah, when the this simple, it's simple. So I'm gonna easily find y. Y is 4 minus 3. Y is 4 minus 3. What is 5? Y is 1. X is 3 and y is 1. Correct? I got some questions. I'll answer them. Give me a minute. Correct? X is 3 and y is 1. So the answers are obtained. Now let's check if the answers are correct. Now x is 3 and y is 1. 3 and this is 1. What is 3 plus 1? 3 plus 1 is 4. So the first equation, that's correct. That's accurate. So x is 3, y is 1. What is 3 minus 1? 3 minus 1 is 2. So the second equation is also correct. So we have taken the answers and we have also checked if they are correct. They are correct. So there's a question: what happens when the coefficients are unequal? If the coefficients are unequal, we are going to make them equal. Let's see how. And the time which the class finishes, like this will take around 2.5 to 3 hours. Let's see. Okay, this is clear. So there's an example in the tube. There's an example in the tube saying that in most cases, the first bullet in the first page, in the second half of the first page, there's a bullet. In most cases, method of elimination can be followed first. So like this, we first use method of elimination and then we use substitution. Yeah, I'm gonna give break in between. Like after finishing simultaneous, we'll have a break. Okay, now see that example in the tube. See the example in the tube, and we are going to follow the same steps we followed for this question. We are going to follow the same step. See, 2x plus y is equal to 25. So this is our first equation, and second equation is x plus 2y, that's equal to 20. This is the second equation. So we must choose someone to eliminate. Like here, are the coefficients of x equal? No. Are the coefficients of y equal? No. They aren't equal as well. So you can choose either. X choose karat hari, y choose karat hari. The coefficients are unequal. So if you got something like this, see, if you got some two equations like this, who will you choose to eliminate, x or y? X, because that's easy. Already the first rule is fulfilled. The coefficients are same. See, so you will choose x to eliminate. You won't choose y. For the easiness of you can choose y, but it will take few steps more. If the coefficients are equal, you choose that unknown to eliminate. So is that understood? How to choose whom to eliminate? Is that understood? If the coefficients are equal, choose them. Good. Okay, I'll repeat. Wait. See, this is your pair of simultaneous equation. This is your pair. So suppose you are given something like this. 2x plus y is 20 and 2x plus 2y is 20. 2x plus y is 25. Correct? Now you will choose x. You are going to remove x. That's going to be easy. Because see the first step in elimination. Second step, make the coefficients equal. The second step, the coefficients are already equal. Then you will choose this one. Correct? Is that understood? You are going to choose what's easy for you. Okay. Now the coefficients are not equal in either of the cases. So I'm going to choose x. I'm going to eliminate x. All right. I'm going to eliminate x. But in order to eliminate x, yeah, like I wrote 2x here for the sake of explanation. Make them at the question. Then I choose like I'll give you a new pair of equations. 3m plus n. 3m plus n is 15. M plus n is 7. See, are the coefficients of m equal? Oh, sorry. Are the coefficients of m equal here? No. Are the coefficients of n equal? Yes. So you will eliminate n. It's easier to eliminate n. Is that understood? If the coefficients are equal, it's easier to eliminate. Good. So that's what I was talking. Like how to choose whom to eliminate in this case. But in this case, the coefficients are not equal at all. So you can choose anyone. You can choose x or you can choose y. Now, is that clear? Right, all right. Now I chose x. You can choose y, no matter. I choose x. Eliminate x. So what's the second step? I must make the coefficients equal. See, the coefficient of x here is 2. So I can make this one 2. How to make the x coefficient 2? How to do that? Yes, by multiplying by 2. Like this is 2, this is 1. I can make this 2. How? By multiplying by 2. But can I only multiply this term? No. In an equation, I have to do something for all the terms to maintain the balance. So I'm going to multiply the whole equation by 2. Is that understood? I can't just multiply this one by 2. Right? I'm going to multiply the whole equation by 2. So I'm going to multiply the second equation by the number 2. So let's multiply. This is 2x, this is going to be 2x, x times 2 is 2x. 2y times 2 is 4y. And 20 times 2 is 40. This is a new equation. This is clear. Yes. Now, just forget this equation because the coefficients are already equal. The coefficients are equal here. Now we can eliminate x. Now we got to see the signs. The coefficients are equal, done. The third step is to check the signs. What can you say about the signs of these two? The signs are same. If the signs are same, are we going to add or subtract? We are going to subtract. Yes. The signs are same, so we are going to subtract. Like you can subtract 3 from 1. You can do this, and also you can do this. You can do both. Subtract and unit. Anyhow, you will have to subtract. But the better thing is to do this because see, the value of 3 is 40. The third equation is 40 and the first equation is 25. 40 minus 25 is easy. Okay. 40 minus 25 gives a positive value. So I'm going to do 3 minus 1. Is that clear? Why I'm going to do 3 minus 1? You can do 1 minus 3. That's perfectly alright. But that will give you a negative answer. 1 minus 3, the right hand side will be 25 minus 40. Right? 3 minus 1, the right hand side is 40 minus 20. Since the signs are same, I chose to subtract. Okay, let's subtract. 2x plus 4y minus 2x plus y is equal to 40 minus 25. 40 minus 25. Now, there's a subtraction mark, so you must definitely put a bracket. 2x plus 4y. The minus gets distributed. Minus 2x minus y. 40 minus 25. What is 40 minus 25? 50. See, I chose to eliminate x. And now x gets eliminated. See, plus 2x minus 2x. It got eliminated. Is that clear? The unknown you chose to eliminate got eliminated. That's what we need. So x got eliminated. There's only y. Correct? Okay. Now the value of y is 5. The value of y is 5. Is this clear? Yes. Okay. Now the value of y is 5. Now I can substitute this value. Like I have one value. So the method of elimination is done. Now I can use the method of substitution in either of these three, like any of these three equations. I can use the method of substitution. Like how? I'm going to substitute y is equal to 5. So in this equation, I'm going to write 5 instead of y, and I'll find the value of x. If I have the value of y, it's easier to find the value of x. So I have one value, I'm going to follow substitution. Let's write by substituting y is equal to 5 in, you can choose any of these. I'm going to choose the first one. I'm going to substitute 2x plus, what is y? Y is 5, is 25. So 2x is 25 minus 5, that's 20. 2x is 20, so x is 10. Value of x is 10 and the value of y is 5. Are these clear? Good. Now, if I give you a pair of simultaneous equations, I'll give you around 5 minutes. 5 minutes is pretty enough, I guess. Can you do? Shall I see? Yeah, good. That's, yeah, okay. Shall I erase this? Yes. Let's go. The pair of simultaneous equations. Let's try. Try and may put the answers. I'll give you 5 minutes. Yeah, I guess the time's enough, no? You guys have sent answers. They are correct. Yes. X is 6 and y is 2. Do you need me to explain? Yes, you need an explanation. Okay. See the same steps. First, we follow elimination. So, we choose whom to eliminate. Let's see if the coefficients are equal. Are the coefficients of x equal? No. Are y coefficients equal? That's not equal as well. So, I'll choose to eliminate y. I'm going to choose to eliminate y. So, in order to eliminate y, I must make the coefficients equal. First, I will name the equations. Wait. This is the first equation. This is my second equation. So, I can make this coefficient into what? This is 1. I can turn this 1 into 2. Yes, into 2 by multiplying the whole equation by 2. So, I'm going to multiply this whole equation in order to make the y coefficients equal. I chose to eliminate y. So, I'm going to focus on y. I'm going to make the y coefficients equal. So, I'll multiply the second equation by 2. 2x minus 2y is 8. Is this understood? We can eliminate x. We can also eliminate x. If you need to eliminate x, I'll do that in this side. Let's see. I chose to eliminate y. So now the y coefficients are equal here. In 1 and 3, the y coefficients are equal. So the coefficients are equal and the signs are different. So what should I do? Should I add or subtract? We must add. Yes, we must add. So I'm going to add 1 plus 3. The first equation and the third equation. So while adding, it's 3x plus 2y plus 2x minus 2y. That is equal to 22 plus 8. See, I chose to eliminate y and now y gets eliminated. Y gets eliminated and I am left with 5x equals to 30. Is this part clear? So if 5x is 30, x is 6. X is 6 and we can substitute the value of x in either of these equations. I'll substitute the value of x. I'll substituting x equals 6. I'm going to substitute this in the second equation. I substitute x is 6. 6 minus y is 4. 6 minus y is 4. Wait. Six minus y is 4. Now I'm going to find the value of y. So I can make y positive by moving it to this side. 6 equals y plus 4. I'm going to take y 4 to this side. 6 minus 4 is y. Y is 2. X is 6 and y is 2. Is this clear? This question is clear? Yeah. Many of you are asking to eliminate x. Okay. You guys chose x to eliminate. Okay. I'll do it quickly. See. Let's eliminate x. Let's try and eliminate x. Eliminate x. In order to eliminate x, I must make this coefficient 3, because the x coefficient is 3 here. I must make this guy 3. So I'm going to multiply the second equation by 3. When multiplying the second equation by 3, I'm left with 3x minus 3 times y, 3y equals 3 times 4 is 12. This is our third equation. Now, let me know the coefficients are equal for x and the signs. What about the signs? the signs are same. So if the signs are same, we'll subtract. I'll subtract the larger part from the smaller part. I'll subtract the smaller part from the larger part. 1 minus 3. I'll do 1 minus 3. Right? 1 minus 3 is 3x plus 2y minus 3x minus 3y is equal to 22 minus 12. Is this clear? Clear, eh? Now you will have to distribute the minus. See, 3x plus 2y. Distribute the minus. Minus 3x. Minus into minus is plus, plus 3y. So that's 22 minus 12. What's 22 minus 12? It's 10. Now I chose to eliminate x, and x gets eliminated. 2y plus 3y is 5y. 5y is 10. So y is 2. We got the same value for y in the first method also. Y equals 2. Now you can substitute anywhere and you will get x equals 6. That's enough neither. So this question, you can substitute and you can check. The substitution is like I'm going to substituting y equals 2. I'll substitute in the second one. That's pretty easy, like small value. I'll substitute in the second one. X minus, not y. Y is 2 now. X minus 2 is 4. X is 4 plus 2, which is 4 plus 2, which is 6. So x is 6 and y is 2. Yeah, for substitution, we can use the second one and also the third one. Any of those. Okay? You can use any of these. Okay, good. Let's move on. Read the second bullet in the first page. In some cases, method of substitution can be directly applied. How is that? Let's see. Like, we don't have to use elimination. We can directly use substitution. Let's see how. Let's see. That in that case, the example is, see, x equals 21 minus 2, right? Equals 21 minus 2. And the second equation is 3y plus x is 27. Okay, let me know what are the unknowns here. What are the unknowns? X and y. The unknowns are x and y. So can you see that they have given a direct value for x? For x, like external value, a direct value for x in terms of y. You can see the value of x in terms of y. Okay? So we can use this thing instead of x. We can write this thing instead of x and see what happens. I'm going to substitute. Let's see, like x, there's x subjected. If x is subjected, this is the value of x. So I'm going to put this value here. Let's see, I'm going to substitute the first equation into the second equation. This is the first equation, the left side, right side of the first equation. I'm going to substitute it directly. So what happens is 3y plus, now what is x? X is 21 minus 2y, that's equal to 27. What did I do? I just changed the value in terms of y. I replaced x with y. Now what kind of equation do we have? Now we have a simple equation. We have a simple equation, yes. Right? Now we have a simple equation. See, what I did, is it understood? Like they have given a value for x directly, so we can use it without making coefficients equal and stuff. We can easily use substitution. In some cases, not all the problems, right? Is that clear? Is that clear? Yes, okay. If they have given a value for x directly, we can use it. So the equations become simple. Now we can find a value for y. See, 3y minus 2y is just y. Y plus 21 is 27. So y is 27 minus 21. Y is 6. Y is 6. Yes, correct. Y is 6. We can use substitution again to find the value of x. So we use two substitutions here, no elimination. This is pretty short and easy than the first one. In some cases, you can use this. Not every question, not in every question. If you are lucky enough, you will get to use this. We got y, and again I'm substituting the value of y. Substituting y equals 6 in. Let's choose. I'll choose 1. I'll substitute y and get a value for x. X is equal to 21 minus 2y. So y is 6. What is 2y? 2y is 12. So x is 9. X is 9 and y is 6. Is this question clear? Why are we finding the value of x? They have already given it. No, they have given x in terms of y. They haven't given the numerical value of x here. X is equal to 21 something. This is not the numerical value. This is the numerical value. Okay. So this is not the actual value of x. We have to find y first, and then we have to find x. If the unknown term came after the equal mark, then we can find directly. Just like if the equal mark, like it's like this. See, there's an equation 3n plus m is 25, and there's another equation n is equal to 25 minus 2n. See, they have given a value directly for n in terms of m. Enter direct value, there's a direct value for n. So we can use substitution in this case. Is that understood? Yeah, okay, all right. So, like, the don't expect always for something to exist like this, like x equal 21. Don't expect like this in questions. There can be. There can be. Okay, all right. So that's the way. That's the way of solving simultaneous equations. That's the way of solving simultaneous equations. I guess you have got an idea of how to solve simultaneous equations. Have you? Have you got an idea of how to solve simultaneous equations? Yes. Okay, then let's try some word problems, because in the exams you don't get two equations and you get to solve. They give you some scenarios, they give you some passages, and then you will have to make simultaneous equations yourself. Right. Let's go to the page number 2. Let's go to page number 2. In page number 2, let's try the first one. Before trying the first one, let's read it. Let's read the note. When constructing simultaneous equations, we must always define the final expected result as unknown terms. I guess, like, I don't know if you got that, but I'll explain what that means. See, in the first question, read the last sentence. What are they asking? How many tickets? How many tickets of each kind? So what are the kinds of tickets? There are adult tickets. There are adult tickets. So number of adult tickets and number of children's ticket. Like, this is what they expect at the end. These must be your answers. Is this clear? Like the final expected results. These are the final expected results. Right? So you must define these as unknown terms. Like I can tell the number of adults tickets, I can let it to be X, and the children's tickets, I'll let it to be Y. So the definition, defining, declaring a variable, declaring an unknown. Is it clear? How to declare? We must declare what they ask. Okay. Now let's read the first sentence. A total of 925 tickets were sold. This question is a bit tricky. You must understand the scenario. They say a total of 925 tickets. Like, what is the number of adult tickets sold? What is the number of adult tickets sold? We don't know a numerical value, we know an unknown value. The number of adult tickets sold is X. And the number of children's tickets sold is Y. So the total number of tickets is X plus Y. That's 925. Is this clear? The total number of tickets is 925. Is this clear? Good. Good. Many of you have understood. Again, I'll repeat. See, we define the unknowns and they say a total of 925 tickets was sold. So we have X number of adult tickets and Y number of children's tickets. So the total is X plus Y. They have given a value for the total 925. We have already built one equation, right? And the second equation, see, and the second equation is using the cost. For example, they say one adult ticket costs $7.5. So, like if there is only one adult ticket sold, so that means 1 times 7.5. Is this clear? Like the revenue, the income generated by adult tickets is this much. If there is only one ticket sold, if I sold one ticket, I get 1 times 7.5. Now, how many tickets have I sold? X number of tickets. So I get 7.5 times money, like 7.5 times X dollars. I don't know the value of X here. I don't know the value of X. 7.5X. This is the income generated by adult tickets. Okay, let me know the income generated by children's ticket. Generated by children's ticket. Yes, exactly. A children's ticket is $3, and there are Y number of children. So multiply these 3Y. So this is the total revenue, total income. 3Y. Yes, exactly. 3.0 or 3Y. 7.5X plus 3Y. This is equal to the total income. What's the income? They have sold tickets for $5,925. This is the total income. Is this clear? Like the construction of two equations. Hard question. Like the construction of these equations is pretty hard, but if you understood this, that's great. Okay, the majority has understood. It's okay. No worries if you didn't understand. I'll repeat the second step again. See, the first step is clear, I guess. The first step is by calculating the number of tickets. This is the number of tickets, number of adult tickets and number of children's tickets. The sum is 925. 925 tickets are sold. And then they are talking about the income, like the money generated. How much money is generated? See, 5,925 rupees is obtained by selling these tickets. So one adult ticket costs $7.5. One adult ticket. So how many adult tickets are sold? X adult tickets are sold. So 7.5 into X. Like this is 7.5x. The money obtained by adult tickets, selling adult tickets. Right? And then one children's ticket costs $3. So the income generated by children's tickets is 3 times by 3y. 3 times by 3y. Right? If you still didn't understand, it's okay. The recording will be uploaded. You can pause it and like try to understand. Like this is no big deal actually, but a pretty hard. Wait, give me a minute. There's some technical issue. Okay. So these are the two equations. Like try solving them. I saw one person has solved already, and the answer is correct. Try solving and find out the number of adult tickets and the number of children's tickets sold. Like these are two simultaneous equations. You can solve them. Good. I have received some values. They are asking for the number of tickets, right? Not the ticket prices. An adult ticket is $7.5 and a children's ticket is $3. That's known. They're asking for the number of tickets. Two people have answered correctly. Three people. Like everyone here has the PDF name. You guys have the PDF name? If you don't have, let me know. Good. Many of you have answered and the answers are correct. Right. So let's. Children's ticket is mistaken. Okay. No, it's not mistaken. Let's see. Let's see. So we must choose whom to eliminate. The same steps: elimination and substitution. We cannot use direct substitution here. So I'll choose to eliminate y. I'll choose to eliminate y. So I'm choosing to eliminate y. In order to eliminate y, I must make the okay, your answer. Okay, good. I must make this y into 3y. Like I must convert this into 3y. So I can multiply the first equation by 3. I'll multiply the first equation by 3, and I'm left with 3x. 3 times x is 3x. 3 times y is 3y, and 3 times 925 is 2775, if I am not wrong. Is the value, right? 2775. And then let's not consider this for a while. See, the coefficients are same and the signs are also same. If signs are same, what should I do? Signs are same. I must subtract. Yes, I must subtract. So I'll subtract the bigger number. Like I'll subtract 2 from 3. Subtract 2 from 3. And I'm left with 7.5x plus 3y minus this 3x plus 3y is equal to, I'll guess this for y, 5925 minus 2775. Sorry about that. Hello? So I just have to simplify. 7.5x plus 3y. The minus gets distributed, minus 3x minus 3y. That is 0, 5, 1, 3. Right? 3150. And then I chose to eliminate y, and yes, y is eliminated now. 7.5 minus 3 is 4.5. 4.5x is 3150. So I can get x by 3150 divided by 4.5. Like if you don't like decimals, you can do 3150, add another 0 and remove this decimal, 45. And this is 45 times 1. And I get this 45 times 7. So we are left with 700. X is 700. How many of you got x equals 700? I saw many answers. X is 700, yes. Yeah, x is 700. Good. So x is 700, like I have made a mess here. X is 700. I'll substitute the value of x. I'll substitute x equals 700 in, I'll substitute it in the easy equation, this one, in the first one. I'll substitute x equals 700 in the first one, in 1. So I'm left with 700 plus y is 925. So y is 925 minus 700. 925 takes 700, that's 225 tickets. So this is the answer. Like this is not the final answer. You must write number of adult tickets equals 700. And then number of children's tickets equal to 25. It's okay. Like if you took x for children and y for adults, that's all right. If that's the case, you will get x equal to 225 and y equals 700. The declaration, it's up to you. Is that question clear for all? Yes. Good. So the main case is, like you must practice how to construct this. Solving this you can do now. You must practice to construct the equation. Correct? Always declare the final result they are expecting. Okay. Let's try the third question. Let's try the third question. Yeah, okay. I'll send you a PDF in WhatsApp. Let's try the third one, and then we'll go to past papers. Like there's 2 past paper questions, and then that's the end of simultaneous equations. We can have a break then after that. Okay. Now try the third question. Like, let me know if you have a difficulty in constructing the equations for the third question. Have you made the equations for the third question? The two equations? No. Okay. Yes. Okay. Hard. Okay. Let's see. It comes with practice. Like, if you practice a few more questions, that's gonna be easy. Let's see. Okay. Yeah, the first equation is correct. Charmika, your answer is correct. Rabbits and hens. Good. Good. Many people have sent the answers. Okay. Now we must know who to declare as a variable. Like, see, there are rabbits and hens. There's a big story. Before that, see the last sentence in the question. How many rabbits and hens are in the farm? So at last they are expecting the number of rabbits and the number of hens. The number of rabbits is, I take the number of rabbits as x. You can take this as A, B, C, anything. You can take R for rabbit, that's perfectly alright. I chose x, number of rabbits x. And the number of hens, I'll take this as y. Number of hens y. Now see, there are rabbits and hens at a farm. Alright, 41 heads and 132 legs in all. What does that mean? How many heads? I know this is pretty weird. How many heads does a rabbit have? One head. And how many heads does a hen have? That's 1, 2. This is not some mutated animal. This is a perfectly healthy rabbit and hen. So one rabbit has one head. So how many rabbits? X. So x plus y, the number of heads. The total number of heads is x plus y. The one head from each rabbit, one head from each hen. X plus y is 41. Same like the previous question. X plus y is 41. This is the first equation. Is it clear, the first equation? And the second equation, in order to do the second equation, let me know. This is general knowledge. How many legs does a rabbit have? Is it 3? It's 4. Yes, it's 4. So 4 legs for a rabbit. 4 legs for a rabbit. How many rabbits? X rabbits. So this is the number of legs from rabbits. The contribution of rabbits for the number of legs. And a hen has 2 legs, right? 2 legs. So 2 legs from each hen, and there are y number of hens. So 2y, 4x plus 2y is how much? Is 132. Are the two equations clear? This equation is for legs and this equation is for heads. We got 2 equations. Now we'll just have to solve. I'll choose to eliminate y. That's easy. Eliminate y. Eliminate y. And then I'm going to multiply this equation by 2 to make this 2. First equation multiplied by 2 is 2x plus 2y is 82. This is a new equation. Now, forget this for a while. The coefficients of y is equal and the signs are same. The signs are same, so I'm choosing to subtract. I'm choosing subtract. I'll subtract third one from the second one. I'll subtract the third one from the second one. Now 4x plus 2y minus this thing 2x plus 2y is equal to 132 minus 82. Then we'll have to distribute the minus. 4x plus 2y minus 2x minus 2y equals, here it's 50. I chose to eliminate y, and yes, y is eliminated. 4x minus 2x is 2x. 2x is 50. So x is 25. How many rabbits? There are 25 rabbits. 25 rabbits. If the number of rabbits is 25, I can substitute 25 here and I can find the value of hens. There are 16 hens in this farm and 25 rabbits. I substituted x equal 25 and I got y. We get y as 16. So there are 6 and 25 rabbits. Is that clear? Is that clear? So I thought of giving the interval after one more question. Is it okay if I do one more question and let's go for the interval, or you guys need the interval right now? How about it? One more. Okay, good. Question first. Good. Let's go for the question first and then interval. The question is the second one. I'll do that with you. Like I'll explain, because this question deals with time. This question deals with time. See, a woman is 30 years old, older than her son now. What are they expecting in the end? They are expecting the present age. Present ages, right? Present age of woman and present age of son. This is what they are expecting. Now you can define those are the variable unknowns. Like I make the percentage of woman to be x and the son to be y. The percentage at the present. And one more thing, in the exam, most of the time they are letting you know, like take x to be the percentage of the woman. In the exam, they say. In here we are defining. In the exam, they are doing that for us. They say take the percentage as x and the percentage of the son as well. Okay, correct. Now let's read the scenario. A woman is 30 years older than her son now. So the age of the woman is 30 more than the age of her son. Is this clear? This is the present situation. The age of the woman is 30 more than the age of her son. Is this clear? Yes, that's clear, eh? The age of the woman is 30 more than the age of her son. Okay, right. And then now we are going to the past. See, they are saying something about the past. 15 years ago, like if the age of the woman is x now, what would have been the age of the woman 15 years ago? The past age. Now the age is x. Well, now the age is x. Before 15 years, for example, guess there's a person, his age is 45 now. The person's age is 45. 15 years ago, his age is 30, like 45 minus 15, right? So if her age is x now, the past age is x minus 15. Is this clear? This is the talk about the past, x minus 15, yes. So what would have been the age of this 15 years ago? The age of the son, y minus 15, right? Yes, the present ages are this. We constructed an equation using the present scenario. Now we need to construct an equation using the past scenario. Let's see what has happened in the past. 15 years ago, she was twice as old. See, 15 years ago, the woman's age, another 15 years ago, the woman's age was two times the son's age. I can't use simply X and Y because this is talk of the past. This is about the past. So the age is X minus 15. The woman's age is two times the son's age. Is this clear? Everybody let me know. The second equation. Yes. Yes. Okay. Good. Yes. Again. Okay. I'll explain again. The first equation is clear for everyone. See, they are talking about something in the past. So the ages of people will decrease when we going back in time. When we go back in time, your age will decrease, right? So if her age is X now, 15 years ago, her age is X minus 15. If this guy's age is Y now, this guy's age 15 years ago is Y minus 15. Now they are saying that 15 years ago, their ages were in the ratio of 2. Like mother's age, the woman's age is twice as the son's age. See, woman's age in English, woman's age, past, in the past. Son's age, see, in the past. The woman's age in the past was twice the son's age. The equation is correct name. So take your time and solve the equation and let me know X and Y. X and Y the percentages of the woman and the son. Let me know. Some of you have sent the answers. Let's see if they are correct. Solve the two equations and let me know the answer. Before solving, see, they have given a value for X directly. So we can use substitution directly. That will be easier. We can use direct substitution. Instead of X, we can write this here. Right? We can use direct substitution without making the coefficient equal and all. We can use direct substitution. Woman 60 and some 30. Let's see. Let's see if it is correct. No, I guess that's not correct. Try again. Try again. It's okay to make mistakes. Take your time. Just tell me your answer is correct. Tilini's answer is also correct. Good. Sahana, your answer is also. Okay, you guys need more time. Shall we start the discussion? Forward. Okay, so let's see. I'm not going to use elimination here. I'm going to jump into substitution because, like I said, there's a direct value for x in terms of y. It's no, y must be 45. The answer y must be 45, not x. And x must be 75. Let's see. See, I'm going to substitute the value of x 30 plus y into this. So I'm substituting substituting the first equation in the second equation. Let's see. When substituting, x, I wrote this 30 plus y minus 15 is 2 times y, it's 2y minus 2 times 15 minus 30. Right? So we have a simple equation now. A simple equation in terms of y. We are going to solve this. See, here it's 30 minus 15. 30 minus 15 is just 15 plus y is 2y minus 30. So I'm going to isolate the y. I'll take this y here and the 30 to this side at once. So what happens? 15 is still here. The minus 30 becomes plus 30. Here it's 2y and the plus y goes there and becomes minus y. So we are left with 45. 45 equals y. So y is 45. Y is 45, which means the son's age is 45. And see the value of x. I'm going to substitute. Y equals 45 in the first equation. That's easy, ne? Yeah, I'm going to substitute the value of y in the first equation. So I'm left with x equals 30 plus, what is y? Y is 45. So the woman's age is 75 years. The woman is 75 years old and the son is 45 years old. Okay? The woman is 75 and the son is 45. You can check if the statement is correct. See, if the woman is 75, 15 years ago, how old was she? 15 years ago, how old was she? The woman is 75. 15 years ago, how old was she? 75 minus 15 is 60 years old. 15 years ago. And the son, he is now 45. 15 years ago, how old was he? 30, exactly, 30. So see, the woman's age was double 15 years ago. The woman's age was twice as the son's age. The question is correct. Our answers are also correct. These are the answers. Is that understood? Yes. So that's the end of simultaneous equations. We have to practice past paper questions. The past paper questions are very similar to these. These kind of questions are in the past papers. Correct? So we will discuss them in tomorrow's session. Right? If we couldn't do that, we'll arrange a separate session for that, and we'll discuss past paper questions from simultaneous equation. Alright. So you guys I'm going to give you a 15-minute break. Like yesterday, you will have a 10-minute like a video and a quiz as usual, and then I'll keep the session idle for 5 more minutes. So altogether 15 minutes. Right? 15-minute break, and you can continue quadratic equation. Before that, quadratic equations are for grade 11. It's grade 11 syllabus. So if you are grade 10, you can wait to see if it's suitable for you. If not, you can leave. It's okay. It's perfectly okay. Simultaneous equations are for grade 10 and 11. Yeah, you can eat and come, or you can eat while you are watching the video. As per your wish. So the break is for 15 minutes. It's 9:12 now. Let's start at around 9:30. Okay, you guys can have the break.
Close your eyes. Now forget what you see. What do you feel?
You gotta put your past behind you. Look, kid, bad things happen, and you can't do anything about it, right?
Right.
Wrong! When the world turns its back on you, you turn your back on the world.
When life gets you down, you know what you gotta do?
I don't want to know what you gotta do.
Just keep swimming, just keep swimming, just keep swimming, swimming, swimming.
Like so many things, it is not what is outside, but what is inside that counts.
You got the makings of greatness in you, but you gotta take the helm and charge your own course. Stick to it, no matter the squalls.
But you remember, Tiana, that old star can only take you part of the way. You gotta help it along with some hard work of your own, and then, yeah, you can do anything you set your mind to.
You must be imaginative, strong-hearted. You must try things that may not work. And you must not let anyone define your limits because of where you come from. Your only limit is your soul.
Who single-handedly destroyed the Green-Eyed Man's undersea labs?
Me.
And who foiled his plan to infiltrate the Olympics with gymnastics cyborgs? Who, Bolt? Who?
Me. But none of them.
You can, Bolt. Because all over this planet, there are animals who feel like they can't.
Young man, sometimes the right path is not the easiest one.
Go. Live your dream.
I will.
Listen, kid. You can't get rid of fear. It's like Mother Nature. You can't beat her or outrun her. But you can get through it. You can find out what you're made of.
You don't have time to be timid. You must be bold, daring.
Bold, daring.
You're braver than you believe, and stronger than you seem, and smarter than you think.
Sometimes you gotta get through your fear to see the beauty on the other side.
The way I see it, you can either run from it or learn from it.
Life's not a spectator sport. If watching is all you're gonna do, then you're gonna watch your life go by without you.
I've always believed that with hard work and a little luck, it's only a matter of time before I'm discovered.
In every job that must be done, there is an element of fun. Find the fun and snap. The job's a game.
The only way to get what you want in this world is through hard work.
All it takes is faith and trust.
Our beat lives within us. You only have to be brave enough to see it.
Look inside yourself, Simba. You are more than what you have become. You must take your place in the circle of life.
is found within.
A true hero isn't measured by the size of his strength, but by the strength of his heart.
What are we gonna do?
Keep moving forward. Nothing's impossible.
From failing, you learn.
Because even miracles take a little time.
Right. So one person had sent the answer for the quiz. You guys need to know how, like, you guys need to know the answers of what. Tilini has done the quiz correctly. Okay, the answers for the quiz is, the numbers are 2 and -1. These are the solutions. Correct? So this question is also done using simultaneous equations. Correct? Try them out in your free time. I'll drop the question in the group again. Correct? So let's continue quadratic equations. Before going into quadratic equations, correct? I'll have to say a few things. In your syllabus, there are two types of quadratic equations. Some quadratic equations have perfect factors. Right? Before that, let me check your knowledge on squares and square roots. Do you have idea on squares and square roots, square numbers, and the roots of square numbers? Yes. Right. Let me know the answer for this. Let me know the answer. What's the answer? Exactly. This is not just 3. This is plus or minus 3. The answer for the square root of 9 can be 3. It also can be minus 3. Right? Like, for example, 3 squared. 3 times 3. What is 3 times 3? 3 times 3 is 9. And minus 3 squared. Minus 3 times minus 3. What is minus 3 times minus 3? Yes, minus 3 times minus 3 also 9. So some values, some numbers have two roots. They have two answers. They have two solutions. Quadratic equations are similar. In a quadratic equation, there is only one unknown. For example, x square plus 5x plus 6 equals 0. This is a quadratic equation. There is only one unknown. What's the unknown here? The unknown is x. The unknown is x. But how many answers will you get for x here? You will get two answers. You will get two answers. In order to get two answers, you will have to factorize this quadratic equation. You will have to factor it out. So I'm not going to teach how to factorize quadratic equations. That's for another session. Like factorizing is taught on grade 10 age. Factorization. If you need factorization, please let me know. I'll arrange a separate session for this. For factorization. Like how to factorize any quadratic equation. Let's do a separate session on another day. Today's session, you won't need the knowledge of factorization. For the O-level question, you won't even need this knowledge. Trust me when I say this. You won't need this knowledge. You have two other methods to solve quadratic equation. That's what we are going to learn. I told the grade 10 people, like this session is completely for grade 11. We are not going to touch this part, factorizing. But if you know factorizing, that's a big plus. That's good. If not, no worries, we can continue. See, for those who know factorization, they'll get an idea when I write this. These are the factors of this equation. X square plus 5x plus 6 is x plus 2 into x plus 3. Sorry, can you please tell me the namings? Confused of? I don't get your question. Yes. Can you repeat me, Hinox? Linear term. Okay, linear terms. Good. Linear terms and constant terms. I'll explain. I'll explain what is linear terms and constant terms. Right. See, you need linear terms and constant terms. Right. A quadratic equation, for example, this is a quadratic equation. This is a quadratic equation. No, we can't get x plus 6, x minus 1. That won't be sufficient for this. Like, first, let's finish this. How do we identify if this is a quadratic equation or not? What's the power of x here? The highest power? What's the highest power of x here? Two. The highest power of x is 2. So if there's any equation with x having the second power, that's a quadratic equation. That is what you call a quadratic equation. Is that understood? Yes. And for linear terms and constant terms, if the power of x is 1, here the power of x is 1, so that kind of terms we call linear terms. These are linear terms. If the power of x is 1, this is a linear term. If the power of x is 2, that's a quadratic term. So the name quadratics comes from this. The highest power is 2. This is the quadratic term. Correct? And this is a constant. This is just a number. So this is a constant term. This is called the constant. Now did you get the idea of what is meant by a quadratic term, linear term, and constant term? Great. See, I'll write a quadratic equation. List down the linear term, the linear term, the quadratic term, and the constant terms here. Minus 11x, yes, this is the linear term. This is the linear term. Why? Linear means the power of x must be 1. Quadratic means the power of x must be 2. This is the quadratic term. This is the quadratic part. And this is what? This is the constant. Is that understood, everybody? And constant. Good. Can it be 3? X plus power? No. If the x's power is 3, the highest power is 3, it is not a quadratic equation. That's out of your syllabus. Right? It's a cubic equation. You don't have solutions for cubic equations in your syllabus. You just have the expansion. That's it. Okay. Highest power of x is 2 in quadratic equation. There must definitely be a x quaterm. There must definitely be a quadratic term in order to be a quadratic equation. Right, let's see. So in the tube, as I said, we are going to skip that first page, like the page number 3. We are going to skip A and B. Like you can try that at home and let me know the answer. We'll do a separate session for that. Factorization. Factorization is not important for this session. Right? With the time being, we'll complete the other 2 methods of solving quadratic equations. Are we good to go? Shall we move on? Yes. Let's move on. Hurry. See. The first method to solve quadratic equation is what? It's completing the square. Completing the square. Completing the square. Remember this. for any quadratic equation, in order to solve any quadratic equation, you must make the equation equal to 0. For example, I have given you a quadratic equation like this. Can you solve it keeping in this form? Can you solve it? No. You must equate this to 0, which means you can take the 1 to this side. So it's x square plus 2x minus 1 equals 0. Now you can solve. Is that clear? Is that clear? Hope it's clear. Yes. Yeah, I can repeat. See, they have given you a question like this. They have given you an equation x squared plus 4x equals 2. And they have asked you to solve for x. Like in an equation, we always find values of x. Like they have asked you the value of x. But you cannot solve this in this format. You must make one side 0. How to make one side 0? You can easily take this 2 to that side, other side. X squared plus 4x minus 2. Now it's solvable. Now it can be solved. Is it clear? Yes, good. And there's another term, a new word you have to learn. It's leading coefficient. Leading coefficient. Leading coefficient. Let's see, what does leading coefficient mean? For example, like I haven't taught you what leading coefficient is yet, but if you can guess, what's the leading coefficient here? You can guess it from the meaning, leading coefficient. Okay, one person has said 5, 3. Yes. What's the leading coefficient? The leading coefficient is 3. Leading coefficient is the coefficient of the quadratic term, the coefficient of the x squared term. In here, what is the leading coefficient? What is the leading coefficient? 1. And here, what's the leading coefficient? The leading coefficient is minus 2. The leading coefficient is minus 2. Why? It's the coefficient of the quadratic term. Is that clear? The word leading coefficient? Okay. Now, let's see how to solve using completing square method. I'll give you an equation. Let's use this equation. X squared plus 2x. Yeah, x squared plus 2x minus 1 equals 0. This is the equation you have to solve. Correct? Now you have to find values for x. We cannot factorize this. For guys who know factorization, we cannot factorize this neither. We cannot factorize this. Right? So we definitely have to use an alternative method. Right? Don't try factorizing this. You won't get answers. Right? Let's see how to do complete square. What's the first step? The first step is make the leading coefficient 1. Method leading coefficient 1. Is it 1 here? Is the leading coefficient 1 in this equation? Yes, the leading coefficient is 1. So our first step is okay. Right. Our first step is okay. And for the second step, don't read that. However, I guess you won't understand. Let's see how to do. I'll explain you how to do. Second step is right? Listen carefully. You convert this into a linear. Like this is quadratic. Second part with just x. You write x squared. You write x instead of x squared. And you divide this coefficient by 2. So this is 2. You half it. What is half of 2? Half of 2 is 1. Half of 2 is 1. And you are squaring it. Is this part understood? I give you another example. See, for this part, see the equation x square plus x square minus 4x plus 5. See, now, wait a minute. Now what we are going to do is, we are going to write x square as x. We wrote x, and we are going to half this. What is half of minus 4? What is half of minus 4? It's minus 2. We are going to write minus 2 and close it with the square. Is this clear? Is this clear? For everybody? Yeah. This part is clear, eh? I took another example for reference. We are following this example. This part is clearly okay. Now, remember, after the bracket, if it's better if you write down, after the bracket, you must always put a minus. After the bracket, no matter what the question is, after closing the bracket and putting a square, you must put a minus here. Is that understood? Yeah. The reason is, if I try to explain you the reason, some people will understand and some people won't. I think it's better I don't explain it. Wait, I'll explain it again. I'll explain the reason. If you feel like you don't understand, don't worry. The reason is this. See, I'm gonna write this, and I did half of this and squared it. So you know the expansion of this, right? The expansion of this is x squared plus 2x plus 2. I'm telling you again, if you don't understand, it's okay. The expansion of this is this. Correct? Now see, we got the answer. Our equation was x squared plus 2x plus 2 minus 1, but we have plus 2. How to make this minus 1? We'll have to subtract plus 1. The expansion is x squared plus 2x plus 1. In order to make this minus 1, I'll have to subtract 2 from here. So definitely there's going to be minus here. Like you try another example. See, I'll do another example. X square, so x square plus 4x minus 5 equals 0. Let's do. What did we do? We wrote x instead of x square, and we half this. Half of this is 2, and we squared it. Now, if we expand this, we get x squared plus 4x plus 4. We get plus 4, but we need minus 5. So we'll definitely have to subtract something. In order to make this minus 5, we'll definitely have to subtract something. What is it? If we transfer it to the other side, we don't need minus. But can we solve the equation like that? Can we solve a quadratic equation without making one side 0? Can we do that? We can't solve an equation without making one side 0. So we must keep it this side. In order to, like, if you didn't get this, I'm repeating, no worries. You will just have to follow these steps. Let's follow. Like, while you are free in your leisure time, you just think, why would it be minus? You think. I'll repeat it. In order to complete a square, we write this as x and we half it. Half of plus 2 is plus 1 and we square it. After this must be minus all the time. All the time this must be minus. After the bracket, this must be minus. And we are writing the square of the inside. What's the square? 1 ke square here. The square of the inside constant. What is it? 1. The square of 1 is 1. And we write the rest, the remaining is minus 2. Okay. This is it for completing square, and we'll have to simplify. I'll do another example parallelly for you to understand. See, x square plus 4x minus 5. Let's see if you understand. See, 5x square plus 4x minus 3. We write x, and we half this, it's 2, and we close the bracket. Is this understood? Is this part understood? Yes? Good. Yes, okay. Now, what would be the sign here? No matter what the question is, I told you what would be the sign. The sign would be minus. The sign would be minus. The sign is minus. And then you are gonna square this. What's the square of the constant term? What's the square of 2? The square of 2 is 4, exactly. 2 squared is 4, eh? 2 squared is 4. And you write the rest. The remaining part is minus 3. Is this clear up to now? Are these two clear? Are these two clear? Good. Now we'll have to solve like a normal equation. Keep this as it is, and minus 1 is minus 2. Now you can take this to the other side. After doing these steps, you can take this. At this step also you can take. Correct? X plus 1 square is equal to 2. Now, is this step understood? Is this clear? I just took that 2 because we have a perfect square here. X plus 1 square. We have a perfect square. Correct. Now we can apply square root. We need x. We can apply square root to the other side. So x plus 1 becomes root 2, and not just root 2. Square cut apply then what happens? It's plus or minus root 2. Is this clear? Okay. Now let me know the answer for this one. What would it be? What would it be? Up to this part. Try this and send me the answer. Exactly. See, x plus 2 squared becomes x plus 2 squared minus 7. Like minus 4 minus 3 is minus 7. Minus 7 is 0. So x plus 2 squared is 7. This becomes positive when taken to the other side. Now we'll apply the root. So x plus 2 is plus or minus square root 7. Okay. So we get answers for x. Here we get x equal, you gotta remove the minus plus 1. So plus becomes minus. Minus 1 plus or minus root 2. See, there are two results for x. One is x equals minus 1 plus or minus. It can be plus root 2, or else x is minus 1. It can be minus root 2. Is this clear? Yeah, I need responses from everyone. Like, I need to know if this is clear. Good. Okay. Good. Okay. So likewise, the same way we can do this. I'll write this here. X plus 2 is root 7, plus or minus root 7. We can take the x value as x equals, we can remove the plus 2. So x is minus 2 plus or minus root 7. Now we get two values for x. The positive value is x equals minus 2 plus root 7. And the negative value is x equal minus 2 minus root 7. Is this understood? Yeah. Use the sign before the square root when doing grade 10 sums. Yes. At grade 10, you don't it's pretty simple. But actually, the complex one is true. There must be two roots for any equation, any quadratic value. There must be plus or minus values. So this is grade level. So this is the actual thing. In grade 10, they are reducing the complexity by only giving the positive answer. But actually, when you root something, when you put the square root to something, it must be plus or minus. The answer must be plus or minus. Good. Is this clear? If this is clear, please note these down in the tube or else in your writing book, anywhere. I'll give you 2 to 3 minutes. Just please note this down. So there's a very good question. Like, can't we further simplify this? Can we? We can further simplify this if we knew the value of root 7. In the exam, they will be giving the value. Like, for example, I'll take for example, if they gave the value of root 7 as 2.75, for example, they say root 7 is 2.75. Then what can you do? You can further simplify this by writing root 7 as 2.75. And the answer will be minus 4.75. Likewise, you can substitute root 7 if you knew the value. Then you will get the exact value for x. Is it understood? You can further simplify this. If we knew the value for root 7. Root 7 is not a perfect square number. So we don't know the value. So shall we move on to a question and then we can go to the final part of the session. Okay, now this question I'm going to do very slowly. Like I am expecting your answers, right? Like each step I'll be asking you questions and you are going to help me through. Okay, let's see the question in the tube. Page number 4. See, use completing the square to find roots of this equation. Use completing the square to find roots of x square plus 4x minus 9 equals 0. Right. Let me do this. First we write x and we go to half. What's the value? What's the value after x? Plus 2. Yes, exactly. Plus 2. Good. And we are closing the bracket. What would be the sign here? The sign is minus. minus, and what would be the number after the minus? The number is 4. Good. The number is the square of 2. It's 4. Eh? It's 4. And then we are going to write the rest, minus 9 equals 0. Now, x plus 2 squared, minus 4 minus 9, what is it? Minus 13. Yes, minus 13. Now, x plus 2 is 13, like x plus 2 squared is 13. We need x plus 2. Then x plus 2 is plus or minus the root of 30. You're gonna remove the square. We are applying square. Root 30. Good. Now, finally, we get values for x minus 2 plus or minus root 30. So, x can be minus 2 plus root 30, or x can be minus 2 minus root 30. Is this clear? Yes. Okay. So quadratic completing the square method is over, but wait a minute. I'll give you something. See, for example, if the sum is like this. Now, can you apply completing square at once? No, because what's the reason? Can you guys tell me the reason? Exactly. Very good. The reason is the leading coefficient is not 1. See the rules. The rule is the leading coefficient must be 1. So in order to make this 1, we need to divide by whom? We need to divide the whole equation by 2. If we divide the whole equation by 2, see, 2x divided by 2 cancels, it becomes 1. 8 divided by 2 is 4. 30 divided by 2 is 15. 0 divided by 2 is 0. Now we can apply completing square, right? Then put 1 in. Okay. Try this out. Apply completing square and tell me the answer. Yes, exactly. Yes, good. Great. See, notice all this. We write x and we write half of this. What is half of plus 4? Half plus 4 is plus 2. X plus 2 squared. The sign must always be minus. Okay? The sign must always be negative. It is always negative. Negative, the root of this thing, the square of this thing. The square of 2 is 4. Minus 15 is 0. X plus 2 squared minus 19. Minus 19 is 0. X plus 2 squared is 19. So what is x plus 2? X plus 2 is the root, the square root of 90. plus or minus. Now we can get x to be minus 2 plus or minus the square. That's it. If they have given the root of 19, you can further simplify and obtain value for x. Completing square, is it clear? Is it okay? Okay, good. Now the final part. Okay. This is like if you don't like if you aren't good with completing square, you can use this thing. It's called the quadratic formula. It's a quadratic formula. Like by using this formula, you can like at once you can get the value for x. You have to do some simplifications. You just have to remember a formula. Amen. Before writing the formula, I will tell you why this is used. Correct? See, for example, I have a expression like this. Like, can I apply completing square to this thing? Let me know if I can. Can I apply completing square? I can. Yes, exactly. I can apply completing square. But see, when applying completing square, things get pretty complicated. See, I write x. What is half of 3? What is half of 3? 1.5. Or else you can write 3 over 2. 3 divided by 2 and put a square. And minus, what's the square of this thing? See, that's where things get complicated. So in order to reduce complications, we can discontinue completing square and we can use the formula. In this kind of cases, we can use the quadratic formula. It's better to use the quadratic formula. Completing square answers enawa. Simplifications ready. See, 3 divided by 2 is 1.5, or else you can keep it as a fraction like this. That's why we use quadratic formula. Is that clear? That's one of the reasons. Right? The next reason is preference. You prefer this over the previous method, you can use this. Right? Or if you prefer the former method, you can use that. Let's try and let's try the quadratic formula. The quadratic formula is x is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. It's a pretty long formula. Many people hate this formula due to the length. Correct? It's quite long. Correct? So many people prefer the completing square method over this due to this length of the formula, due to the formula being a pretty lengthy. Correct? But there's nothing complex here. See, we need to know what is A, B, and C. For example, if I write if I write some quadratic equation like this is A, and this is B, this is C. Did you understand what A, B, and C is? A is the coefficient, leading coefficient, correct? B is the coefficient of the linear term, of the x term, and C is the constant term. Is that clear? What A, B, and C are? A, B, and C. Okay. All right. So we'll just have to substitute these values, and we are getting a value for x at once. Correct? Let's try this question itself. Let's try this. Right? This is the question. 3x square minus 4x plus 5. See? So the value of A is 3 here. The value of B is, what is the value of B? Is it just 4 or minus 4? The value of B is minus 4, exactly, minus 4. And the value of C is 5. So we can get X, we can write X like minus B. If B is minus 4, what is minus B? Like if X is minus 1, then minus X is 1. So if B is minus 4, what is minus B? Just 4 new. Just 4. Like minus B is minus B. So minus into minus becomes plus. It's just 4. Correct? Due to B being negative here, the negative version of B is positive. Plus. Take a clear name. Minus B plus or minus the square root of B square. What is the square root of B square? Like what is B square? B square is 16. 16 minus 4AC. It's 4 times A times C. So this is going to give us 60. Harada? 60 dhamma. The answer will be pretty complex. Harada? Like this is the way. 4AC can 4 times A times C. So 16 minus 60. This is going to give us a negative number. Correct? This is a negative number. Square roots for negative number, therefore we can continue this. Like this is an example I just gave it on the floor. Correct? I gave this example. Correct? With the floor. So we'll try a standard example. Come to the question. Come to the page number 4. Find the roots of x square minus 3x plus 7 equals 0. Let's try and find the roots. Right? Using the quadratic formula, see x squared minus what? X squared minus 3x plus 7 equals 0. What is A here, B and C? Let me know A, B and C. Yes. A is 1. B is minus 3. Yes, B is minus 3. And C is 7. Here too, I guess we will end up with a negative answer. Let's see. The question is pretty. Let's change the question like this. Make this minus 8. Make this minus 8. Make this minus 8. Make this minus 8. If not, you will end up with an imaginary answer, not a real answer. Imaginary numbers, those stuff. That's out of syllabus. Let's see. X, to get x to be minus b. What is minus b? What's minus b? Minus b is 8. Yes, minus b is 8. Plus or minus square root. B squared. What's b squared? 64. Yes, b squared. Minus 4 a c. Okay? Minus 4ac. I'm looking at the formula and just writing the values. Divide by 2a. Divided by 2. Correct. So x is going to be 8 plus or minus 64 minus 4 times 7 is 28 divided by 2. So we can get x to be 8 plus or minus square root 64 minus 28 is 36, right? So we are like, is it clear up to this point? Is it clear up to this point? Yes. Clear. So we know the root of 36, ne? We are going to end up with a perfect answer here. What's the root of 36? It's 6. Yes. X is, there is already plus or minus, so this is just 6. 8 plus or minus 6 divided by 2. So there are two answers. X is 8 plus 6 divided by 2, or X is 8 minus 6 divided by 2. Right? So 8 plus 6 is 14 divided by 2 is 7, or else 8 minus 6 is 2, 2 divided by 2 is 1. We get two answers for x, x equals 7 or x equal 1. Is this clear? The final question for today, correct? The final question for today will be the 2021 O-level question. The final question for today's session is a 2021 O-level question. Let's see. Let's read it. Let's read it and give it a try. I'll give you right. You need time to note this down, or can I erase it? Okay. Let's. Like in the exam, you can either use completing score or the formula or the quadratic formula. You can use either. They don't specify use completing score or use quadratic formula. You can use anything you wish. Let's see the question. The length of a side of a square lamina B, right? There is a square lamina. Its name B is 4 centimeter more than the length of a side of a square lamina A. Like there are two squares, one is A and one is B. Like they are talking something about lengths. Before that, read the last sentence. Read the very last sentence. By taking the length of a side of a square lamina A as x, they say take the side length x. This is x. In simultaneous equations and quadratic equations, when writing past paper questions, always read the final sentence first. Nothing like you will take more time to find out what's happening. Read the last sentence, very last sentence. They say take this to be x. X unknown. Now again read the first sentence. The length of a side of a square lamina B is 4 centimeter more than that of A. Like if this is x, this is 4 more than x, then what would it be? This is x. This is 4 more than that. What is the side length? Exactly. X plus 4, or else 4 plus x. Is this clear? Is this clear? Yes. If any doubts, please let me know. This is a square with side x, and this is a square 4 centimeters more than x side length. And then, like the sum of the areas, like the area of B plus the area of A, is equal to 88. The sum of the areas is equal to 88 square centimeters. So what's the area of B? How to find the area of a square? If the square side length is L, what's the area? It's L squared. It's L squared. So the area of B is x plus 4 squared, and plus the area of A is x squared. This is the sum of the areas. This is the sum. So we are going to add these areas together. Hi. What's the expansion for this? Somebody let me know the expansion. X plus 4 square. What's the expansion? Binomial expressions expansion. square of a sum. Yes, it is exactly x square plus 8x plus 16. This is x square plus 8x plus 16. You can try x plus 4. If you don't know the expansion, you can do this twice and check. This would be the answer. X square plus 8x plus 16 plus x square is 88. Now, what kind of an equation is this? Is this simple, simultaneous, or quadratic? So quadratic. This is a quadratic equation, right? The highest power of x is 2. This is a quadratic equation. In order to solve a quadratic equation, it must be equal to whom? It must be equal to 0. So, abhi 88 to hum ye baat kar rahe hain. While taking 88 to this side, I'm going to add this stuff. X plus x square plus x square is 2x square plus 8x, correct? Plus 16, and I'm taking this 88 to this side in order to make this equal to 0. Right? Now I'm ending up with 2x square plus 8x. Here it's 16. Yeah. 272, right? Minus 72 is equal to 0. Is this clear? You understood why I took this 18 to that side, right? In order to solve it. Like by taking the length of side as x, show that it satisfies the equation. Main equation in the question, maybe something like this. Question there is something like x square plus 4x minus 36 equals 0. So, like, are these two different? What has happened? Exactly. We'll have to factor out 2. Or else we have to divide this whole equation by 2. We can divide it by 2. May equation, mulu equation with 2 and divide karo. What could we end up with? We'll end up with the required equation. Correct. Let's divide it by 2. So 2x squared divided by 2 is just x squared. Correct, x squared. And then 8x divided by 2 is 4x. 72 divided by 2 is 36 plus 0. We got the satisfactory equation. Correct? Is this clear? Now you can use any method. You can use completing square or quadratic formula. Just try and find the value of x. Try and find the value of x. It's better to use completing square. Completing square would be easier, I guess. Take few minutes and try complete. Or else quadratic formula no matter. Hi. Good. So we'll just have to use either of the methods. I'll just completing the square. You guys, it's up to you. So this is x and half of the coefficient is 2, x plus 2 square, and the term after the bracket always must be minus. The symbol must be minus and the square of 2. The square of 2 is 4. And write the rest. X plus 2 square minus 40 is 0. Now x plus 2 square is 40. And x plus 2 is plus or minus square root 40. So we'll end up with x equals 2 plus or minus square root 40. Okay, now have they given the value for square root 40 in the question? In the question, exactly. 40 is an entire surd. Yeah, it's minus 2. It's minus 2. Right? 40 is an entire surd. We can decompose. We can make this a surd. Correct? See, x is minus 2 plus or minus root 40, but in the question they have given this root 10 equal 3.16, I guess. Yeah, root 10. They are given root 10. We have root 40. How to eliminate this? See, plus or minus 40 is 4 times 10. We have to factorize. 40 is 4 times 10. You know the square root of 4. What's the square root of 4? The square root of 4 is 2. Therefore, I'm gonna take 4 outside. When coming out from the square, it becomes 2. 2 times root 10. So we know the value of root 10. It is 3.16. So I'll further simplify. I'll use this side to further simplify. See, x is equal to minus 2 plus or minus 2 times 3.16 is 6.32. Now, x has two values, the positive one and negative one. The positive one is minus 2 plus 6.32 and the negative one is minus 2 minus 6.32. Which would fit? The positive answer or the negative answer? Like if we go for the negative answer, this is minus, see, this is minus 8.32 and the positive answer is 4.32 if you simplify. So a length cannot be negative. A length cannot be negative. So we can say this is false because x is positive. A length cannot be negative. If you write a length cannot be negative, that's sufficient. This is wrong. So the side length is 4.32. That's it. We have found x. So almost we have finished, like we have finished equations, but there's another question, Roman number 2. What is it? Show that the difference in the areas is 8 into something. Right? Let's finish the session by doing that also. Right. Let me know if this is understood. Are there any doubts? No doubts. Right. So the difference in areas, see, there are two laminas, B and A. Now we know the side length of A. A is 4.32 centimeters because A was x. We found the value of x. B is 4 plus x, which means 4 plus 4.32. That is 8.32 centimeters. This is 8.32 centimeters. So they are asking for the difference in the areas. Let's see the difference. Correct, right? The question says the length of a side of B is 4 centimeters more than the length. Yes. So, yeah, let's go. The difference. the area of B. Clearly, B is greater than A. Like B is 8.32 of side length. A is 4.32. So this is definitely greater than this. So when finding the difference, we are going to do, this is the area of B, right? Square minus the area of A. Right. Difference of two squares. See, that's difference of two squares. If it's A square minus B square, how can you factorize it? A square minus B square आगे थी उसको मुझे factorize करना. Yes, A square minus B square is A minus B into A plus B. So similarly, we can factorize this. This is A, consider this to be A and consider this to be B. So A minus B into A plus B. A minus B into A plus B. Right? See, this is clear. This part, this is okay. This is not quadratic equations. Right? This is grade 10, like binomial expressions. This is binomial expressions. Is this part clear? Clear. Right. Let's simplify. 8.32 minus 4.32 is clearly 4. Minus color balance, make answer 4. And here it's 12.64. It's 12.64. But in the answer, they are given something like this. Answer ke pinnan kya mehe bada. Right? So, mata 12.64 liyanna puluwan. 12.64 කියන එක මම ලියන්න පුළුවන් නේද? 6.32 into 2 කියලා. මේක බලලා තමයි මේක කියනවා. I can write this as this way. So 4 by 2 by multiply කරලා දාන්න. 4 times 2 is 8. 8 times 6.32. This question is pretty, like the Roman number 2 is pretty tactical. Like if you understood this, like what can I say? If you understood this, that's very good. Let me know if you understood. If you didn't, I can repeat. It's a matter of the simplification. Understood. Good. So this is 2021 O levels for you. The whole question. 2021 O levels. So sorry, yes, 2021. That's it for today's session. We have done 3.5 hours of Zoom meeting. Good. Happy that you are here until the end. So let's end up the session. See you tomorrow in the question discussion. God bless you.